In this video, we're going to talk about atomic number and mass number, as well as electric charge. What is the atomic number and what is the mass number? Now, before we can answer those questions, let's talk about some things that we can see in the periodic table. If you take out your periodic table and you go to the element nitrogen, you're going to see this. You're going to see a 7 above it and a 14.01 below it. Now you might be wondering, what do these numbers represent? The top number, the 7, this is the atomic number. The atomic number is represented by the symbol Z, and it's equal to the number of protons. So nitrogen has 7 protons. The number of protons, or in this case the atomic number, identifies the element. So if you have an atom with 7 protons, you automatically know that you're dealing with an atom of nitrogen. Now what about the bottom number? Notice that the bottom number is not an exact whole number. It has a decimal value. This is not the mass number, but rather it's the average atomic mass. There are different types of nitrogen atoms known as isotopes. There's nitrogen 14 and there's nitrogen 15. So this is nitrogen 14. When it's written this way, the bottom number is the atomic number. The top number is the mass number, represented by the symbol A. Nitrogen 15 looks like this. Nitrogen 14 has a mass of 14. Isotope nitrogen 15 has a mass of 15. So these are isotopes. They have the same number of protons, but they differ in the number of neutrons and the mass number. So now you know the difference between the atomic number, the mass number, and the average atomic mass. So to review, this is the atomic number. This is the mass number. The mass number is a whole number. If you don't see a whole number, you're dealing with the average atomic mass. Now, which of these two isotopes is more abundant? Would you say nitrogen 14 or nitrogen 15? Notice that the average is closer to 14. Therefore, nitrogen 14 is far more abundant in nature than nitrogen 15 because the average is closer to it. Now let's look at another example. Let's consider the element boron. On a periodic table, you'll see a 5 on top of boron, a 10.81 below it. Now, boron is composed of, there's many isotopes, but there's 2 main isotopes. There's boron 10 and there's boron 11. Those are the 2 most common isotopes of boron. So looking at this information, what is the atomic number for boron? What is the mass number? And what is the net electric charge? So looking at the 5, notice that the 5 is the same for all isotopes of boron. The atomic number is 5, which means that boron has 5 protons. The mass number, represented by the symbol A, is different. It changes for different isotopes. Here the mass number is 10, the mass number is 11 for that. This bottom number here is the average atomic mass. Now since the average is 10.81, which isotope of boron is more abundant in nature? Would you say it's boron 10 or boron 11? 10.81 is closer to 11 than it is to 10. So that means that boron 11 is more abundant than boron 10. Now the charge is going to be 0 because we're dealing with atoms. When dealing with an atom, the number of protons and electrons are the same, so it's electrically neutral. When they're different, the atom becomes an ion. Ions have different numbers of protons and electrons. An ion with more protons will have a positive charge. Ions with more electrons have a negative charge. Now let's work on some word problems. Determine the atomic number, mass number, net electric charge, and the identity of the element given the following information. So we have 6 protons, P is 6. We have 7 neutrons, N is 7. And we have 6 electrons. So the first thing we need to do is identify the element. And you can identify the element by knowing the number of protons, which is the atomic number. So we already have the answer to the first part. The atomic number Z is the number of protons, which is 6. So if you go to the periodic table and you look up which one has an atomic number of 6, look for the whole number, the smaller of the two numbers, you'll find that this is carbon. Now we're going to put the atomic number on the bottom. So whenever you have an element, you want to put the atomic number on the bottom, the mass number on top, and on the top right, you want to put the charge. Now, to get the mass number is the sum of the protons and the neutrons. So we have 6 protons, 7 neutrons. That gives us a mass number of 13. Now, to calculate the net electric charge, the charge is going to be the difference between the number of protons and electrons. So we have 6 protons and we have 6 electrons. Since there's no need to put -6 here because we've already incorporated the negative sign in front of the electron symbol. So notice that the number of protons and electrons are the same. This means we're dealing with an electrically neutral atom. Atoms have equal number of protons and electrons. When these two numbers differ, then we have an ion. We'll have a net charge. So right now there's no net charge. We don't have to put a 0 here. We just leave it the way it is. So the atomic number is 13. The charge is 0. So we have an atom of carbon. This is isotopic carbon-13. Now let's move on to part B. We have 9 protons, 10 neutrons, and 10 electrons. Go ahead and determine the atomic number, mass number, net electric charge, and the identity of the element. So the atomic number is the same as the number of protons. It's 9. The mass number is going to be the sum of the protons and the neutrons. 9 plus 10 is 19. Now the charge, this is not going to be 0 because notice that the number of protons and electrons are not the same. They're different. So because they're different, we no longer have an atom, we have an ion. The charge is going to be the protons minus the electrons, so that's 9 minus 10, which is -1. So we have an ion with a -1 charge. The last thing we need to do is identify the element. So we need to look at the number of protons. Take a minute, go to the periodic table, and look for an element with an atomic number of 9. Look for the lower of the two numbers. And you should see that this is fluorine. Fluorine has an atomic number of 9. And for this one, we're dealing with fluorine 19. It has a mass number of 19. And we have an ion with a charge of -1. So that is the identity of the element. It's fluorine, and we're dealing with the ionic form of fluorine. Now let's move on to part C. We have 13 protons, so P is 13, 14 neutrons, and 10 electrons. Feel free to work on that problem. So we know the atomic number is the same as the number of protons. That's going to be 13. The mass number, A, is the sum of the protons and the neutrons. So 13 plus 14, that's going to give us 27. That's the mass number. The charge is the difference between the protons and the electrons. So the charge is going to be P minus E. So that's 13 minus 10, which is positive 3. Now let's go ahead and identify the element. So looking at the atomic number, which is 13, and using the periodic table, we can see that this is going to be aluminum. Aluminum has 13 protons, and it has a mass number of 27. The charge is 3 plus. So that is the identity of the element for part C. And it's not an atom, but it's an ion, since it has a charge.